Good day, grade 12 learners. Welcome to today's physical science lesson. My name is Mashudu Mamburu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. So today we'll be focusing on revision of organic molecules. So we're going to focus on question 2 and question 3. Question 2 being nomenclature or naming of organic molecules, including isomers, including the primary, secondary, and tertiary alcohols and haloalkanes. Then we'll look at physical properties. Remember, in grade 12, we are doing 3 physical properties, which is your melting point, boiling point, and vapor pressure. Now, with no any wasting of time, these are our objectives that were taken exactly from the exam guidelines. So we are saying, in terms of definitions, you must be able to define what is organic molecules. You must be able to define organic molecules. Remember, we're saying these are compounds that contain carbon, compounds containing carbon. And then we are saying you must be able to define homologous series. I know by now you must be singing those definitions to say this is a series of organic molecules that can be described by the same general formula. Or you can say each member differs from the next by CH2 group. Now you must be able to define functional group. Remember, we're saying functional group is a bond, it's an atom, it's a group of atoms that determines the physical and chemical properties of an organic molecule. You must be able to define as well what we refer to as hydrocarbons. Hydrocarbons, remember, we're saying these are organic molecules that are made up of hydrogens and carbons only. Only is very much important, because if you just say hydrocarbons contain or are made up of hydrogens and carbons, your definition will be wrong. It must be they are made up of hydrogens and carbons only. And these hydrocarbons, you are saying they can be saturated or unsaturated. And when you say they are saturated, we are saying they have no multiple bonds between carbon atoms. And when we say they are unsaturated, we are saying they have multiple bonds between carbon atoms. Sorry. Now we're going as well to look at the primary, secondary, and tertiary alcohols, as well as primary, secondary, and tertiary haloalkanes. So remember, for it to qualify to be primary, we're saying the carbon that is bonded to the hydroxyl, to the OH. The carbon that is bonded to the OH there is bonded to one other carbon. Hence, we are saying that is primary. And we are saying secondary, the carbon that is bonded to the OH is bonded to 2 other carbons. For tertiary, we said the carbon that is bonded to the for tertiary alcohols, we said the carbon that is bonded to the OH is bonded to 3 other carbons. So I'm just reminding you all these definitions, because by now you must be singing them, you must be able to practice them. We can say define them as alcohol, primary, secondary, tertiary alcohols, or we can say primary, secondary, or tertiary haloalkanes. Now, in terms of isomers, we are referring to them as structural isomers, because we are saying these are organic molecules with the same molecular formula but different structural formulas. We have 3 types of them, which is said is the chain isomers. Chain isomers, we said these ones, they belong to the same homologous series, and we are saying they have the same molecular formula but different types of chain. Positional isomers, we are saying these ones, they have the same molecular formula but different position of the substituent, of the side chain, or the functional group. So don't forget, in terms of positional isomers, we refer to 3 things that can be in different position. It is the substituent, it's the side chain, it's the functional group. And lastly is the functional isomers. These ones, the functional isomers, they belong to different homologous series. So you will understand that the chain and positional isomers, if you talk about chain isomers, you'll see that they are all coming from the same homologous series. If you talk about positional isomers, they must all belong to the same family or the same homologous series. But when it comes to functional isomers, as the name says, the functional group must be different. So they have the same molecular formula but different functional group. Hence, they belong to different homologous series. And we said for functional isomers, it's simple for you to remember. We said cake here, which means carboxylic acids and esters, aldehydes, and ketones. So don't forget the functional isomers, that they belong to different homologous series, whereas structural the chain isomers, same homologous series. Positional isomers, they must all come from the same homologous series. I hope you get that. And then the other thing we're going to focus on is the issue of IUPAC naming. So we're going to revise naming. Remember, now we are focusing mostly on the questions. We want you to do a problem solving so that you have all the strategies and you are ready to answer any question that can be asked on under this topic of organic molecules. So we are saying you must be able to write structural formula when given IUPAC name or molecular formula. You must be able to, and we are saying here the compounds must be restricted to one functional group. I want to emphasize that to say the functional group will only be one. There is no way we will give you, for example, your alkenes, then you have two double bonds in one structure. So we don't do dienes in grade 12. We only do one double bond because according to the exam guideline, we're saying these compounds must be restricted to one functional group. It is only in the case of haloalkanes where these substituents can be two, the substituents, which in this case will be your dibromo, dichloro, difluoro, diiodo, if you have two of them. So, but for all the other, for all the functional groups that we're having, we're saying only one functional group per structure. So we won't have one structure that have more than one functional group. So you have to understand at all times there will be only one functional group per structure. It's only for our substituents, which are our chloro and bromo, which we call halogens, that you can find more than one halogens in a structure. But when it comes to functional groups, remember, we're not treating the bromo and the chloro as the functional group. We're treating them as the substituents when we're doing our naming. So I wanted to emphasize that so that you have understanding that at all times we'll always have one functional group per molecule. Now, haloalkanes, we are saying these ones, they can have two of them. And then we have the alkyl substituents. Remember, for alkyl substituents, we're talking about your methyl and your ethyl. I think in the previous lessons, we were able to indicate to you that when you have CH4, we call it methane. But immediately when you remove one hydrogen there, it becomes CH3. And then that CH3 is alkyl group, which is called methyl. So a methyl is a methane that is one hydrogen short. Now, ethyl, it will be ethane. Remember, ethane is CH3. And so we're saying ethyl will be CH2, CH3. Then you know that we are running short of one hydrogen. I think you got that, and it helps you as you prepare for this lesson. And we are saying these alkyl groups, which is your ethyl and methyl, they are restricted to a maximum of 3. So we won't have one structure that have more than 3 alkyl groups. We can't have so it means now we can have 1,2,3 trimethyl, say heptane or whatever the structure is, but the limit is that there cannot be more than 3. So you won't be saying tetramethyl or more than 3 substituents in one structure. I will demonstrate that when we are doing our naming of structures. And we are saying when you are naming haloalkanes, please always remember that halogen substituents. So hence I said our halogens, your bromo, your chloro, your iodo, your fluoro, we are saying these ones, we are treating them as substituents. So as substituents, they have no preference over alkyl groups. So those are things that I wanted to emphasize at the beginning of this lesson so that we are able to move together. I hope that clarifies and makes you ready for the lesson. As we always do, we always look at the pre-knowledge to say you have done this in grade 10. You have done the covalent bonding, which is what we are focusing on, which is covalent bonding, which is sharing of electrons. And we are saying this happens between non-metals. Non-metals plus non-metal, they are forming your covalent bond. You have done ionic bonding and metallic bonding, which will be interest when we are doing dealing with the other topics like electrochemistry, where we are using ionic bonding, where we'll be talking about metallic bonding, how the metals behave. But for now, under this topic, we are focusing on sharing of electrons, which is covalent bonding. Now, as we usually do, we just to appetize you to start with the baseline to say, don't forget, these small things are the most important things, because if you do well in question 2, you will do well in question 3 and question 4. Hence, we are making sure that your foundation is much proper. Now, if we look there, we are saying which one of the following illustrated electron arrangement represents the carbon atom. So you are able to check that the carbon is number 6 in the periodic table. It has 4 valence electrons, which means that this one cannot be correct because it has 6 valence electrons. And if you look at B, it has 2 valence electrons, 2 electrons in the outermost shell. So it cannot be carbon. But carbon, how will you know? It will have 6 electrons in total, and 4 of them will be valence electrons, or will be on the outermost energy level. Remember, we are still emphasizing that carbon can only form 4 bonds. Please, let's not make those mistakes as I move forward. Now, in terms of your answer, you are able to choose number C, because C is showing you now that that is your answer for that particular question. Now, baseline activity 2, which type of bond is carbon most likely to form? You know, I've told you that carbon bonded to carbon, non-metal plus non-metal, carbon to hydrogen, carbon to chlorine. We are saying all those are your covalent bond. And then you are able to choose covalent bonding as your answer. In this case, number B is a correct answer. Now, activity 3. Identify the chemical formula of sulfuric acid. Sulfuric acid is very much important in these organic molecules. Remember, we're using sulfuric acid as our catalyst for as many reactions as you can think of. Remember, during esterification, we are using sulfuric acid as a catalyst. During addition of water, which we call hydration, we're using sulfuric acid. When we are eliminating water, again dehydration, we are using sulfuric acid as a catalyst. So sulfuric acid, you must hold it dearly close to you, because it's one of the catalysts that we really need in terms of this topic. So we are saying, don't forget, sulfuric acid is H2SO4, and it will be used as a catalyst for all those reactions that I've mentioned, with the exception of hydrolysis. Remember, when we are substituting using OH, a halogen with an OH, we call it hydrolysis. We don't use sulfuric acid in that direction, which is something that we have talked about even in the past. Now, the correct answer is sulfuric acid, which is H2SO4. Now, which of the following compounds represent methane? I think by now all of you know what is methane. Methane is the hydrocarbon that is the first alkane that we are having, which is CH4 now, which is number C there, or letter C as given in the answer there. Now let's look at activity 5. Which of the following compounds is not a hydrocarbon? Which one is not a hydrocarbon? Remember, hydrocarbons, we said they are made up of hydrogen and carbons only. They are made up of hydrogens and carbon only. So you can just check. This one passes. It is made up of hydrogens and carbons only. The second one passes. It is made up of hydrogens and carbons only. Number D passes. Is made up of hydrogens and carbons only. The only one that is not made up of hydrogens and carbons only, it is number C. Hence, we are going to choose our answer as number C, or letter C, alphabet C, as our answer, which is CO2. Carbon dioxide is not a hydrocarbon. In fact, carbon dioxide is an inorganic molecule. Now, terminologies. We are always saying, know all the definitions, know all the terminologies. You must know how do I identify an alcohol. You must know the general formulas of alcohols, of aldehydes, of alkanes, which is CnH2n plus 2, of alkenes, CnH2n, and then the alkyl group, which I've talked about already, to say our alkyl group is a group formed by removing one hydrogen atom from an alkane. I've showed you the two that we are going to focus on in terms of our syllabus, which is your methyl CH3 and your ethyl CH2 CH3. And we said there can only be 3 of these alkyl groups per molecule. Now, alkynes, we know the alkynes, carbon-carbon triple bond, CnH2n minus 2 as the general formulas. The carbonyl, it's important that you know that the carbonyl, they are found in ketones. And in ketones, this carbonyl group, we are saying that is surrounded by 2 carbons. So we always do this in revision, in preparing you now. The carboxyl group, the COO, which is COOH, remember we said there are only 2 homologous series that has two oxygens, which in this case is your esters and carboxylic acid. So you know when you see a structure with two oxygens, you know it's either an ester or a carboxylic acid. And then we are moving again to say now you must know the carboxylic acid, you must know the chain isomers. I already indicated that they have the same molecular formula but different types of chains. Condensed structural, we said we do not show all the bonds here on the condensed structural formula. It's the one where we are writing CH3, CH2, we can say times 2 because the chain is increasing, CH3, and then you are able to see that that will be butane with 4 carbon, which is C4H10. So it's important to know all types of formulas. We can't stop to emphasize that from the general formula, molecular formula, structural formula, condensed structural formula, and empirical formula. You will see as we do questions will always ask you using these formulas. If you don't understand the formulas, then you won't be able to answer the questions. The functional group that I've already defined to say is a bond, an atom, a group of atoms that determine the physical. Remember, physical properties is question 3, and the chemical properties, which is question 4, of a group of organic molecules. So all those terminologies, we said they are very much important. The issue of haloalkanes, the issue of functional isomers, homologous series, we said they are described by the same general formula, or each member differs from the next with a CH2 group. A hydrocarbon, I've already done that. IUPAC naming. IUPAC stands for International Union for Pure and Applied Chemistry, which is used now for naming of organic molecules. So we always follow the laws when we're doing our name. I've talked to the issue of the molecular formulas, or what is organic chemistry. We said it's chemistry of carbon compounds, the issue of positional isomers. And then the most important thing that I've emphasized was the issue of the primary alcohols. Remember, for it to be primary, we're saying that the carbon atom that is bonded to the OH is bonded to one other carbon. Now, you will see then that we can have a primary alcohol or a primary haloalkane. The same here, we're saying that the carbon that is bonded to the halogen is bonded to one other carbon. And then when it comes to saturated compounds, we talked about to say they have no multiple bonds between carbon atoms. So they are made up of single bonds, no double bonds or triple bonds. Now, secondary alcohols, again, we're saying we are focusing on the carbon that is bonded to the hydroxyl group. We're saying that carbon is bonded to two other, and we're saying secondary is this carbon is bonded to two other carbons. And we have a secondary alcohol and a secondary haloalkane. Now, when it comes to structural formulas as well, we're showing here, you show all the bonds. And when it comes to tertiary alcohols, we're saying the carbon that is bonded to the OH is bonded to 3 other carbon. Hence, we're saying that is tertiary alcohols. It's important that we always remind you of this terminology, so that all the time you know the importance of terminology as far as chemistry, organic molecules are concerned. Now, tertiary haloalkanes, the same. The carbon that is bonded to the halogen is bonded to 3 other carbon. So I hope you have all those. And then, without wasting time, because we want to focus on problem solving, this is not necessarily a teaching period. It's a period where we're talking about strategies to say, how are we going to answer questions? Now, IUPAC naming, we're saying writing IUPAC names of organic compounds. We are going to follow these 3 parts. We have 3 parts of IUPAC naming that makes it easier for us to name. We are saying we will focus on the suffix, which is the functional group. So the first thing you will do, you will look to which functional group is this structure belonging to. To which functional group? The functional group will tell you the family, the homologous series. So the first thing, we want to know the family which the organic molecule belongs to. How do we know that? We look for the functional group, which is our suffix. So it's very much important. So you will check, and when there is no any other functional group, only carbon-carbon single bonds and carbon-hydrogen single bonds, you know those will be the anes, which is the alkanes. Now, the number of carbons in the longest chain will give us the parent, and the prefix, which in this case is our substituents. I want to emphasize this one to say our substituents, we said, is bromo, is chloro, is methyl, and ethyl. And you have seen from the exam guideline that no preference between bromo, chloro, fluoro, iodo, methyl, and ethyl. We all treat them the same. So you won't be saying bromo is preferred compared to others. It will only be preferred if they are in the same carbon using the alphabetical preference. You will see when we do questions. I don't want to dwell on that because questions will answer what we're talking about. This worked example, I like it because first you must be able to break down the structure so that you can know how to build it. If you can break something, it means you can be able to build it. So let's look at this one. We are given 1,2 dibromobutane. We are saying as we break the structure, we will always start with the suffix to say it is an ane, which means it's made up of carbon-carbon single bonds and carbon-hydrogen single bonds. And then you can see it's a but, which means we have 4 carbons. We have 4 carbons in the longest carbon chain. And we have 1,2 dibrom, which means we have a visitor, we have a substituent in carbon number 1 and carbon number 2, we have bromo. So hence we're saying 1,2. So you can see that we always start with the suffix, we go to the parent, we go to the prefix. And in terms of the prefix, we said our prefix, we are referring here to bromo, your chloro, your iodo, your fluoro, and methyl and ethyl. And we said these are allowed to be more than 1, but they cannot be more than 3. So you cannot have more than 3 alkyl groups per compound. I hope that helps you. Let's look at number B there, which is propanol. You can see the al there is from the aldehyde. So you know that we're dealing with an aldehyde because of the al, which is our suffix. Propan means 3 carbon, that is saturated. So you're able to see that here you're dealing with a saturated structure. There are no double bonds between carbon atoms, and then you are having an aldehyde is the functional group. Then that is propanol. I hope that helps you. You will see when you do real questions, then you will be applying all this knowledge. Now, with no any waste of time, we are going to start with multiple choice questions. I want to take you through here and have understanding to say when you're dealing with multiple choice, you are given 4 options. Of those 4, we are saying there are 2 that which are obviously incorrect answer. Remove them because those are distractors which are there to distract you from getting the correct answer. So we're saying you are given C4H10 as number A, C3H8, C2H6O, and C3H8O as number D there. But the question is saying, for which one of the following molecular formula are chain isomers possible? Now, remember, we have understanding that you are going to spend approximately 2 to 2.4 minutes for this question. So you have 2 minutes here to do this question. So it's important that you can go around and try and draw to check that, okay, if I'm having C3H8, for example, will I have chain isomers? You know that to have a chain isomers, you can't have chain isomers here because if I'm to write this one, C3 like that, or I just take this carbon, I put it there, it's now still a straight chain. It's still a straight chain. So it's not possible that you can have a chain isomer when you have 3 carbons. So you will see it's even worse when you are having 2 carbons. You can't have a chain isomer. When you're having 3, as I said, you can't have those type of isomers when you are having chain isomers, when you are having that number of carbons. So it's only when we chain isomers start from 4 carbon and up. So we are saying chain isomers will start from butane up or whatever the homologous series that you are in, but the minimum number of carbons for you to have chain isomers, there must be 4 carbons. I hope you understand, because I can write 3 carbons like that and then be able to indicate a branch. Remember, they are chain isomers because they have branches. So you can't have a branch when you have 3 carbons, because no matter where you put, it will remain one longest chain. So it's important that you understand that it's only butane that can have an isomer, which in this case is 2-methyl propane, which is the isomer of that, which is C4H10. So we can draw butane, we can draw 2-methyl propane as the isomer. So I think I've unpacked it for you nicely to say the chain isomers minimum we must have 4 carbons, then we will have chain isomers. So I'm able to move there, which shows our answer as number A. Let's go to 1,2, the second question. Remember, this was adapted from May, June multiple choice questions 2023. We are saying which one of the following compounds has the lowest vapor pressure. Remember, lowest vapor pressure, by implication, it implies that highest boiling point. So you just look for highest boiling point. You know that the one with the highest boiling point has the lowest vapor pressure. And if you can check here, we're having an alkane. Remember, alkanes, they have London forces. We're having here in number B, our aldehydes. Remember, aldehydes, they have London forces and dipole. So they have dipole, which is stronger than London forces for alkanes. And then if you check number C, we're having an alcohol which have one side of hydrogen bond. So it has one side of hydrogen bond. And then if you look at number D, we're having a carboxylic acid which has two sides of hydrogen bonds, which means a carboxylic acid is the one now that will have the highest boiling point, which means it has the lowest vapor pressure. What makes it to have the highest boiling point, sir, is because, remember, as the strength of intermolecular force increases, the boiling point increases. I want to caution you again to say you cannot use directly proportional in paper 2 when we're dealing with chemistry. You talk about the relationship between the independent and the dependent variable without using directly or indirectly proportional. So in this case, we are going to say number D or letter D or alphabet D is the correct answer. The reason being it can form, or it has two sides of hydrogen bonding. Which means it has the strongest intermolecular forces as compared to the other three given organic molecules. I hope you got that and you are able to move with that to say the one with the lowest vapor pressure, it has the highest boiling point and it has the highest strength of intermolecular forces, and more energy will be required. As long as you have the highest strength of intermolecular force, the greater strength of intermolecular force, or as long as you have stronger intermolecular forces or strongest intermolecular forces, you will definitely need more energy to overcome the intermolecular force. And if we need more energy, it means the boiling point will be higher. Remember, when we talk about energy here, we're talking about your heat. When you heat, you'll need more heat to be able to boil D as compared to the other organic molecule. I think I've explained that, and it will help you as we move forward. Now, question 1.3 from the same May June multiple choice questions. The type of organic compound formed when a haloalkane is heated in the presence of concentrated strong base. I want to emphasize the issue of reaction conditions, learners. I'm telling you, if you understand reaction condition, you're going to enjoy reactions. Question 4, you're going to enjoy it a lot as long as you know that, okay, concentrated is for elimination. It's not only concentrated, it goes with heat. It's concentrated is for elimination and it goes with heat. And we're saying dilute is for substitution, it goes with mild heat. All those will help you as you prepare yourself for your exams. Now we are saying, because we're using a concentrated strong base, concentrated sodium hydroxide, concentrated potassium hydroxide, we are saying we're going to eliminate. We're going to eliminate, and when we eliminate, we've always formed double or triple bond. So we form unsaturated compounds. So in this case, it means now we have a haloalkane, we're going to remove a hydrogen and a halogen, and then hence this will be dehydrohalogenation, and we're going to form an alkene here. The type of organic compound formed when a haloalkane is heated, when we eliminate. So we're eliminating a hydrogen and a halogen and a hydrogen. Hence, we are going to get number B as our correct answer. Now, let's move now to real questions. May, June 2023, question 2. you will have seen that majority of questions you are given a diagram with many organic molecules there. It's important that you go through them. You are able to analyze your question before you answer the questions that you are given. Now, let's look at this one. We are given the statement says study the table below. The keyword there is study. So you cannot go and answer the questions unless you have understood the table that you have been given. So study the table below. Only when after you have studied and understood the table, you are going to answer the questions that follow. So let the order be in that way, to say the first thing that you are going to do, you are going to study the table. And after studying the table, you are going to answer the questions. But a precondition is that you will answer questions after you have studied the table and understood what is happening in the table. Leave the questions alone, understand the table first. Now, for example, we are given number A then. We are given an organic molecule, a long organic molecule, which if you check, the first thing you will check there, you're going to check that, oh yes, it's only made up of carbon-carbon single bonds and carbon-hydrogen single bonds. So you will know that this is an ane, a suffix of this structure is going to be an ane because it's carbon-carbon single bonds and carbon-hydrogen single bonds. That is the first thing you will see. And then the next thing, you're going to look for the longest carbon chain to say how many carbons do we have here. So you can start wherever you want. You can start from here. You say, okay, if we say this is carbon number 1, it will be 1, 2, 3, 4, 5. You can go that side or you can go that side. It's the same. So we have 6 carbons in the longest carbon chain. So learners sometimes they make a mistake of thinking that a longest carbon chain must be a straight chain. It cannot bend. Sometimes we just bend the structure, but it's still the longest carbon chain. In this case, the longest carbon chain is the one that starts from there. 1, 2, 3, 4, 5, 6. The other one can say, no, sir, why don't we start from this side in terms of our numbering? Let's check. You can number and say this would be 1, 2, 3, 4, 5, 6. So still you are having 6 carbons in the longest carbon chain, and you can check the other options. They won't give you 6 carbons. So you are able to see that this must be a hex because 6 carbon is hex. So you know that this must be a hexane. Now, if you start numbering from this carbon, the substituent comes at carbon number 3, which is here. We're having this substituent. I want you to have an understanding there. If you start numbering from this carbon, for example, or from this carbon, the substance comes at carbon number 2, which is this one. Carbon number 2. So you are having those 2 options of numbering from there or there. But we want to number closest to the substituent. So the correct numbering is the one that is closest to the substituent. In this case, when I start numbering from here, this is carbon number 2 and number 1. In carbon number 2 already, I have a substituent. So I can start numbering from there to say, this is my carbon number 1, 2, 3, 4, 5, 6. So I will number them like that. And I know that in carbon number 2, I have a methyl. In carbon number 2, I have a methyl. In carbon number 2, I have a methyl. And then I move 3, 4. In carbon number 4, I have another methyl. So I have a 2,4 dimethyl because I am having methyl in carbon number 2, another methyl in carbon number 4. So it's important, learners, that you always look at it that way. So you know that the name would be 2,4 dimethyl hexane. You will see that I'm saving time because when I go to the questions, already I will have had an understanding of what is happening. So if I'm saying I'm having 2,4 dimethyl hexane, remember, in like terms, a number and a number is a comma. Unlike term, a number and an alphabet is a hyphen. So we're using the hyphen between a number and an alphabet, but between a number and a number is a comma. So always have that like terms, comma, unlike terms, hyphen. I think you got that. So I'm saying 2,4 dimethyl hexane. Then you are having that as your structure. You said it belongs to a family called alkanes. And then there are so many things you can ask yourself. How many carbons do we have here? If you check, we are having 8 carbons. We're having 8 carbons. How many hydrogens? You can count them. you will find that we're having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 hydrogen. So it's C8H8D, but it's a branch structure. So it means if I give you C8H18, you won't know whether it's a straight chain or it has branches and what. You just know the molecular formula that the maximum number of carbons we have is 8. So it's impossible that I'll give you C8H18 and say name it, because it can be having branches. There are branches. You know that when it's like that, it can be octane or the isomers, the chain isomers of octane. I hope you have the same understanding. You go to number B as well, you do the same to say, what are we given? We're having an all here. Where do we find the all? The alcohol in carbon number 1. Hence, you're going to say this is a 1 all. And then how many carbons? 3. 3 is prop, but this is saturated. There are no double bonds or triple bonds. So you will say is prop and no double bond, triple bond, so it's propan. Please don't forget the AN there. That AN is very much important. You can't say prop 1 all. You'll say propan 1 all. So you are able to see that is propan 1 all. It's a primary alcohol. Remember we said primary alcohol, the carbon that is bonded to the OH is bonded to one other carbon. And then you are given there your C4H8O. Very much important that you draw, when you're given that, draw the structural formula, because the structural formula is going to show you what structure you have. Because remember, you have with 1 oxygen, you have 3 homologous series that have 1 oxygen. It's your aldehyde, your ketones, and your alcohol. So AKA, when you see 1 oxygen, you know it's either an aldehyde, a ketone, or an alcohol. So how will you know that whether this is an alcohol or a ketone or what? So it's important for you now. It's important for you now to know that this can be an alcohol, a ketone, or an aldehyde. So very much important piece of information. You are given there a condensed structural formula. That's what we refer to as condensed structural formula, because not all the bonds are shown. So you are able to check how many carbons do we have. We have 1 plus 4 here. So it means CH2 times 4. We have 4 CH2s. So it's 1 and then plus 4 is 5. We are given a CH. When you see a CH within a structure already, you know that we have a multiple bonds there, and then CH2. So you can see that there is a double bond between CH2 and CH there. It is good to draw the structural formula in order for you to understand the question. I hope that helps you as you analyze the questions. Now let's go straight to questions, and then we can answer questions. And I hope what we have done here is going to help us when we answer questions. Now, the first question was, define the term unsaturated hydrocarbon. Unsaturated hydrocarbon. So you know that these ones, these are organic molecules that have multiple bonds between carbon atoms. So you'll say these are organic molecules that have what? Have multiple bonds between carbon atoms. They are saying write down the letter that represents unsaturated. That represents the one with the unsaturated, which means which have multiple bonds between carbon atoms already. Because you have analyzed, it becomes easier for you to say D is unsaturated. The IUPAC name of compound A, it helps you that you have analyzed. Look at that, it's 3 marks. So already you have analyzed, you know that in carbon number 2, you have a methyl. In carbon number 4, you have another methyl. Then it's a 2,4 dimethyl hexane. And you are going to get 3 marks. Remember, when you are allocating the 3 marks, we'll give you 1 mark for hexane there, for getting the longest carbon chain, that is hexane. We'll give you another mark for getting the substituents, that we have a methyl and another methyl. We'll give you another mark for the whole structure, that is correct, and the numbering, everything, and including commas and hyphens. Then you are able to get 3 marks there. So please, these are a lot of marks that you can collect. And if it was 2023, remember 3 marks is 1% for the whole physical science subject. So it's important that you get those 3 marks of naming. IUPAC name of the positional isomer of compound B. So they're saying compound B, which is propan 1 all. You see the importance of analyzing. You are seeing that, okay, the OH is in carbon number 1. So what will be its isomer. A positional isomer, remember we said they have the same molecular formula but different position of the functional group. So where is the OH moving? The OH is moving to carbon number 2, hence it becomes propan to all. So it becomes easier for you to change the position there to say from propan 1 all, where there is 1, I will write a 2, which means the OH will be in carbon number 2, which now becomes a secondary alcohol. So the question was, write down the name of the positional isomer of compound B. So you can say propan 1 all, because propan 1 all is B. They don't want the name of B. They want the name of its positional isomer, which in this case will be propan to all. I hope you get that and you have that understanding. Now, 2.2.4 says, what is the IUPAC name of compound D? Again, you have analyzed the question, you have seen, and I said it's important for you to even draw the structure to say, already we have seen that we have 7 carbon in the structure, but in carbon number 1, which is the first CH2 on your right there, we have a double bond between that CH2 and that CH, and then that shows you that when you have a double bond, it's an in, and you know that when you have an in, you are checking how many carbons do you have there. Then you are able to say, okay, we have 7 carbons. So you can see that we are having a hept, which is 7 carbons is hept. Remember, in terms of our loss, we'll start first with carbon number, with the functional group, which is the in there. So we know that it's an in, and where is that in? It's in carbon number 1. So the double bond is in carbon number 1. So you are able to say this is a 1 in. And how many carbons in the longest carbon chain? We said it's 7. 7 is hept. So you are able to say hept 1 in. So will I be wrong if I write heptene? We are going to mark you correct. Heptene, unless if it was a special case where the double bond can be carbon number 2, carbon number 3, carbon number 4. But we always emphasize that show the position of the double bond. So the correct answer is hept 1 in. I hope we are moving together. Now we say balance equation using molecular formula for the complete combustion of compound A, and that has 3 marks. For space sake, I will do it this side to say, now in this case, we are asked to write a balance equation using molecular formula. It means you can't use structural formula because the instruction is saying molecular formula. That's why it's important that you always remember all the types of formulas that we have. So you are going to do that for compound A. Remember compound A, we've counted. Molecular formula, we're simply saying count. How many carbons? Remember, molecular formula shows the type and number of the atoms. The type and number. How many types do we have? We have carbons and hydrogens only. How many carbons? We said we have 8 carbons. We've counted them. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 carbons. Hydrogens, we counted them. We said they are 18. So you will have there for 2.2.5, you'll have a C8H18. And because we're saying combustion, it means we are burning it in oxygen. That is oxidation. We are burning it in oxygen, and then that must form carbon dioxide and water. You see, merely for writing your reactants correct, for writing your product correct, already you have 2 marks. Now you have 1 mark to fight for. How do you get that mark? We are saying to get the mark of balancing the equation, we are saying what you are going to do, in front of the carbon dioxide, you'll write N there. How many carbons do we have here? So you're going to write 8 there. You're going to say 8 CO2. In front of the water, you will write N plus 1, which means 8 plus 1. What is 8 plus 1? It's 9. So you'll have 9 H2O. And then you will be able to write your C8H18 plus O2. Now, it means if you check, you have 8 carbons, you have in terms of hydrogen, you have 18, H18, you have 18 hydrogens, and 9 times 2 is 18. So your carbon and hydrogen, you are able to balance them by using the N and the N plus 1. I hope you get that. Now your responsibility is to count the number of oxygens on the right hand side, which in this case is 8 times 2, which is 16, plus 9 times 1, which is 9. And if you check 16 plus 9, my calculator says that is 25. So you know that you must write 25 over 2 in front of the oxygen. You must write 25 over 2. So we are not allowed to write a fraction as our coefficient there. So hence you're going to multiply the whole expression by 2, and you will get 2C8 H18 plus 25O2, which becomes 50 oxygens, gives us 8 times 2, 16 carbon dioxide plus 18 H2O. And if you check then, you will see now that, okay, you are having 16 times 2 oxygen, which is 32. 32 plus 18 is 50, and this side you have 50 as well. So you can see that everything is what is balanced. So it's important that you follow that road in order for you to get the third mark. Remember, the first mark you got it for writing the reactants correct and the carbon dioxide plus water as your product. Don't forget, the main aim of combustion is to produce energy. So energy is part of our product there. So you are able to do that, and then you got your 3 marks for 2.2.5. So the only answer that we are expecting, we don't necessarily want to see how you got the answer, but we want to see you the balanced equation that you are writing, which is that one. I hope that helps you and you are able to go and balance those reactions. Now, let's move now to the next question. It says the formula C4H8O. This one, number C again. They're saying it represents 2 compounds that are functional isomers. And you and me, we know that functional isomers, we always remember with the word cake. We are saying that these are carboxylic acid and esters. But carboxylic acid and esters all have 2 oxygens. The only functional isomers that we do in grade 12 that have 1 oxygen is your aldehydes and ketones, which means they are saying in 2.3, that statement is saying C4H8O represents aldehyde and ketone, because they are saying they are isomers, they are functional isomers. So it's aldehyde and ketone. Now, the first question they gave you there, they said define the term functional isomer. We did that in our introduction to say functional isomers, these are organic molecules with the same molecular formula but different functional group. In this case, we're having aldehyde and ketones. Write down the structural formula of each of these 2 functional isomers. Their structural formula for 4 marks. Look at the number of marks there. You are able to collect as many marks as possible. And then you will move and say, I'm going to draw 4 carbons because the structure is 4 carbons. The difference is that with aldehyde, the C double bond O is in carbon number 1, the terminal carbon. It's in carbon number 1, the C double bond O is in carbon number 1, and that's what we call butanal. It's important that when you draw your esters, you must name them, because always your isomers, I mean to say, when you draw your isomers, name them, because when you name them, it reminds you that the name of isomers will always be different. You can't have 2 isomers that have the same. You can't have isomers that have the same name, I mean to say. So this is butanal. It means the other isomer, functional isomer of this one, cannot have the same name as butanal. So what you're going to do, you are moving the C double bond O. Remember the ketones, we said it's a C double bond O that must be surrounded by 2 carbons. So you are moving the C double bond O there. You still write 4 carbons because it's C4. And then you write the double bond there now, are surrounded by 2 carbons. It must be surrounded by 2 carbons, the C double bond O. Then this is a ketone. And I said you must always remember to name them. And a ketone like this, you are going to name it as butanone. Maybe you're asking yourself, say, why don't you name it butanone, for example? Why don't you tell us about the position of the functional group? Remember, when we say butanone, it's when we want to differentiate it from its positional isomer. So butanone, there is, even if I move the C double bond O to this carbon, it will still be butanone, hence it has no positional isomer. So I am not obliged to show the position when I'm doing the naming. But if I have 5 carbons, for example, if I have 5 carbon structure, for example, your pentanone, like that, I will be able to say this one, if we have a double C double bond O in carbon number 2, I will refer to it as pentan 2O. Why am I telling you about the position? Because I can move the C double bond O to carbon number 3, which in this case it will be pentan 3O. So you can see that we show the position in the naming. We show the position when we are having a positional isomer. If we can be able to have another structure with a C double bond O somewhere and it has a different name. So in this one, it's butanone because there is no positional isomer of this one. But when it comes to this one, we're saying this is pentan 2O. Why are you telling us about the position? Because we have a positional isomer which is pentan 3O. So we want to differentiate between pentan 2O and pentan 3O. I hope you got that the position helps us to differentiate between the positional isomers in this case. So you got your marks, you are richer, 9 marks in this page. Now, if we move to the next question, I like this one because now we're talking now your questions, your physical, your chemistry now. To say you are given a 2 gram sample of compound E. So compound E is CXHY or Z. So we're not given, or we don't know how much is X, or what is the value of X, what is the value of Y, what is the value of Z. And we want you to do problems like this one as many times as possible so that you learn and you have the understanding. So we're given that, and they are saying we have 1,09 grams of carbon, we have 0,18 grams of hydrogen. Remember, our structure is made up of carbon, hydrogen, and oxygen. And if you check in terms of our syllabus, the structures with carbon, hydrogen, and oxygen, it can be your aldehyde, your ketone, your ester, your carboxylic acid, and another structure with oxygen will be your alcohol. So those 5, they all have carbon, hydrogen, and oxygen. So in this case, we're not 100% sure which structure it is, but we know the structure has carbon, hydrogen, and oxygen. And we're saying it's a 2 gram. Now, look at the beauty of science here. So we're given carbon, we're given hydrogen, we're given oxygen. Now for carbon, we're given the mass as 1,09. The mass of carbon is 1,09 grams. The mass of hydrogen were given as 0,18 grams. Now, it dictates here to say, okay, if I have 2 grams, of which 1,09 belongs to carbon, 0,18 belongs to hydrogen, it means the remaining from that 2 grams belongs to oxygen, which means now we can be able to use our calculator to say, okay, what is 1,09 plus 0,18? And my calculator is saying the total of those two is 1,27. So if I take 2 minus 1,27, if I say 2 minus 1,27, which is the carbon and hydrogen, I will remain with the mass of oxygen. So I'm able to say, okay, let me say 2 minus 1,27, and then the mass of oxygen will be 0,73 grams. So I have the mass of all of this, my learners. So you know that the mass. But you know that when you have the mass, it's easy for you to calculate now the number of moles. When you have mass, you can calculate the number of moles. For carbon, you know that number of moles, I'll just write the formula here because it applies to all of them, is mass over molar mass. So we're able to know that for carbon is 1,09, the molar mass of carbon is 12. So we'll get the answer. And then for hydrogen is 0,18, and you know that hydrogen is 1. And then for our oxygen is 0,73 divided by for oxygen is 16, the molar mass of oxygen. So you see, it's important that you are armed with all that information in your predictable to say, I will go and look for molar mass of carbon, I will go and look for molar mass of hydrogen, the molar mass of oxygen, because I'm given the mass. I always say this, that when you're dealing with chemistry, when you see mass, you see the number of moles. You see that I can now calculate the number of moles because I have the mass. Now, if we were to do our calculations using a calculator, we'll say 1,09. We'll say 1,09. You divide it with 12 for carbon, and then we get 0,0908. 0,0908. You see, I don't want to round up or round down too much because I don't want to lose my answers here. So I got 0,0908 for carbon, and then for that one, 0,18 is 0,18 because we're dividing by 1, and then 0,73. When you divide it by 16, you are getting 0,0456, yeah, something like that. 0,456. So now you know, Monsieur, we're going to take the smallest number of moles to divide the rest of them to get the ratio between them. Which means now I will divide this one by 0,456, and then I'll get 1 obviously. So we have 1 oxygen. So we know that we have 1 oxygen, and then for our hydrogens, we'll say 0,18, and then we'll divide it by the same 0,456, and then we get 4. We get 4 there, 3,94736. So we got 4 there, and then you take your 0,0908. You divide it by your 0,456, and then you are able to get your answer there, in this case, which is 2. So you are able to get 2 there. And then once you got that, you can see that, okay, in our structure, we have a C2H4O. That's what we're having. Now, but we are given here on the statement that the molecular mass of compound E is 88 grams per mole. So now if you check here, you're going to check the molecular mass for this one. To say what is the molecular mass for this one, you're going to say, okay, let's take our carbon, which is 12 times 2, and then you're able to get your 24. Plus your 4 hydrogens, you get your 28, plus 16. And if our math works well, we're saying 24 plus 16 is 40, plus 4 is 44. So we get 44 grams per mole. So we are able to see that, okay, this one, we must find the number, how many of this C2H4, which means we are having the empirical formula here, the simplest whole number ratio of this molecule is C2H4. So we must be able to say that 44 grams times number n, because we don't know how many they are, is equals to 88 grams per mole. And then if you divide both sides by 44, you will be able now to get n equals to 2, which means you're going to multiply the empirical formula with the 2 there, and then you're going to get your C4H8O2. So we are able now to get the molecular formula, because the question said get the molecular formula. So the molecular formula will be C4H8O2. And then that is what you were asked, and you are able to get your 6 marks. So you can use this method, or you can use the percentage method. But this one is one of the simplest, because you are given your mass in grams. You just find the number of moles for all the 3 of them. After that, you divide by the smallest number of moles to get the ratio, to get your empirical formula, and then you look for n, you multiply your empirical formula with 2 in this case, and then we got C4H8O2. I hope this helps you and you are ready. You are saying, I must practice as many questions as possible that have questions like this one that came in 2023 May, June. Now, let's look now at question 3. They're saying, learners investigate the boiling points of the 4 organic compounds given below. So you have your butanone. Remember, your butanone here, you are referring now to your to your ketones, and your ketones, you know, they have dipole. It's important to always remember what we are saying here. We are saying we have 9 homologous series, which is your triple A, and C. Those are the 9 homologous series. And we are saying the first 3, these ones they have London forces. These are the hydrocarbons. They have London forces, only London forces. And then Hague, which is your haloalkanes, your aldehyde ketones and esters, these ones we are saying they have dipole. They have London forces plus dipole. And the alcohols, we are saying these ones have one side of hydrogen bonding. Write it in full. One side of hydrogen bonding. And then carboxylic acid, they have 2 sides of hydrogen bonding. So don't forget that. They have one side of hydrogen bonding, 2 sides, which means of all of them, the carboxylic acid are the strongest because they can form 2 hydrogen bonds. That's the meaning of that, to say they have 2 sides of hydrogen bonding, whereas the alcohols, they have only one side of hydrogen bonding. Now, the question now says, okay, we've analyzed. So we said this one is dipole. This one is one side of hydrogen bonding. This one is two sides of hydrogen bonding. This one is one side of hydrogen bonding. But now, because this one, you can see the mistake there. There's no E there. Now, this one is 2-methyl propan 1-ol. You can see that this 2-methyl propan 1-ol compared to butan 1-ol, they all have one side, but butan 1-ol has the longest chain. It's less branched. Butan 1-ol has no branch, but 2-methyl propan 1-ol is branched. So obviously, when we have branches, we are decreasing the strength of intermolecular forces. So what am I saying? I'm saying it helps you to always organize this in a way that you will understand. To say, okay, butanone is the first one in terms of the weakest intermolecular forces. The first one will be butanone, followed by 2-methyl propan 1-ol. Why 2-methyl propan 1-ol? Because butan 1-ol is unbranched, and 2-methyl propan 1-ol is branched. And when you have a branch, you decrease the strength of intermolecular force. Now, number 3 will be your butan 1-ol. So you are arranging them in terms of increasing strength of intermolecular force so that it becomes easier for you to answer the question. And then the last one will be propanoic acid. We just said that this one has 2 sides. Propanoic acid has 2 sides of hydrogen bonds. So hence it's the strongest intermolecular forces compared with all the other 3. Now, define the term boiling point. So you are able now to define boiling point. Remember, we're saying a boiling point is not a point. It is a what? It is a temperature at which the vapor pressure is equals to the atmospheric pressure. You write it in full and you get all your 2 marks. And we are saying, let's always write our definition in accordance with the exam guidelines. So we're saying it's a temperature at which the vapor pressure is equals to the atmospheric pressure. The vapor pressure of a substance is equals to the atmospheric pressure. Now, which compound, butan 1-ol or 2-methyl propan 1-ol, will have the higher boiling point? Already you have put them in order to say, okay, 2-methyl propan 1-ol has less strength as compared to butan 1-ol. We said because it is branched. It is branched. Once it has a branch, once you have branches, you are decreasing the strength of intermolecular forces. So explain. That is for 4 marks. So you are able to get 4 marks by doing this question to say, okay, the question is which compound? You must answer that question. Which, it means choose between the 2 of them. So you are saying it is butan 1-ol. Then you say why? Why butan 1-ol has higher boiling point than 2-methyl propan 1-ol. Now we're going to say, okay, butan 1-ol, all of them, they have one side, but the difference here is that butan 1-ol is less branched, or has no branch, less branched or has no branched, while this 2-methyl propan-1-ol is branched. So this one is branched, but butan-1-ol is less branch or no branch for butan-1-ol. And then since there is no branch, it means it has a stronger intermolecular forces than 2-methyl propan-1-ol. So butanol has stronger intermolecular forces than 2-methyl propan-1-ol. And the other thing that was saying if that is the case, more energy is required to overcome the intermolecular forces in butan-1-ol than in 2-methyl propan-1-ol. What are you saying, sir? I'm saying simply apply the dice there. The dice was saying, what is the difference? What is the difference here? The difference in the structure. What is the difference in the structure? And then we're saying now the difference in the structure is that butan-1-ol has no branch, while 2-methyl propan-1-ol has a branch. What is the number 2? We're saying we talked about the strength of intermolecular force. What is the strength? Which one is stronger? Butan-1-ol. The intermolecular forces in butan-1-ol are stronger than the ones in 2-methyl propan-1-ol. And then the energy required. Then we are saying more energy is required to overcome the intermolecular force in butan-1-ol than in 2-methyl propan-1-ol. I hope this will help you and you will collect these marks, and you can see that in fact physical properties, a very nice question that you must do and understand. Now let's look at question 3 now. They are saying, let us invest the boiling points of the 4 organic compounds given below. Now we're going to look at the the boiling points as we talked in the previous page. Now we're saying the curves P, Q, R, and S below we obtain from the result of the investigation. X represents a specific temperature. Which physical property is represented by temperature X? Remember, we're investigating boiling points. So it will have been easier for you to say this must be boiling point. So this is boiling point. X is indicating the boiling point of P. Now, which curve, P, Q, R, or S, represents the following? Now, you see the importance of you putting them in terms of increasing strength of intermolecular force, because you will have said butanone is the weakest in terms of the comparison here, as the weakest intermolecular forces, followed by 2-methyl because it has a branch, 2-methyl propan-1-ol, it follows, followed by butan-1-ol with one side, same as 2-methyl propan-1-ol. And then the highest we said is propanoic acid because it has 2 sides of hydrogen bonds. So you are able to look at it that way. So if you have done that, you can see what we're doing. We're simply saying this is your F is the lowest boiling point, is for butanol. Your R is for 2-methyl propan-1-ol. Your Q is for butan-1-ol, and your P is for propanoic acid. And by so doing, you have answered majority of questions that you are going to be asked in this question. You will see now they are saying butanol. You simply go there and say butanol is S, lowest boiling point. Propanoic acid, you see now the way the questions are being asked, they are mixed up. So sometimes you become confused. Hence we are saying nicely go and arrange them in terms of the strength of intermolecular force so that you are not confused. Now, propanoic acid, you said is the highest, is P, the highest boiling point there. 2-methyl propan-1-ol, already you have allocated it R. So you're able to say that is R. So it becomes easier for you now to answer the question. Give a reason for the answer in 3.4.2. Why are you saying R is 2-methyl propanol. So you must be able now to talk to what we're talking about. Say 2-methyl propanol is branched. This one, it is branched. And if it's branched, this 2-methyl propanol, it will have a less strength of intermolecular force. The strength of intermolecular force will be weaker compared to, for example, propanoic acid, or compared to butan 1-ol. So you will see that we are saying this one, because of the branch, it has now, remember it's propan 1-ol, it has one side of hydrogen bond. So you can compare it to propanoic acid, for example, to say propanoic acid will have what? Two sides of hydrogen bond. So you are saying that, okay, as compared to propanoic acid, 2-methyl propan 1-ol, because now it has one side and is branched as well. So you can see there are two factors that works against it if you are to compare it even with butan 1-ol or propanoic acid. And then you are that question was for 1 mark. So you can refer to many things. You can refer to it, compare it to P, to say it has one side and P has two sides, and then you can say it's branched. If you are comparing it with the butan 1-ol, that it is branched, hence it will have less strength of intermolecular force, or less energy will be required. So any of those will help you to get that 1 mark. Give a reason for your answer, which is what we just did now. Now let's move to 2023. November 2023. This was a multiple choice question. It says, which one of the following represent a straight chain saturated hydrocarbon? You know, saturated hydrocarbons are alkanes. We only have one type of saturated, and we know that is CnH2n plus 2. Very much important, because if you are to check number 5, because already we are looking for alkanes, this is the formula. If we were to substitute 5 here, we'll have C5. 2 times 5 is 10, plus 2, it must be 12. So you know that the alkanes we are looking for, if it has 5 carbons, it must be C5H12. Number A fails that description. Number B fails that description, because if we have 5, it must have 12, but this one has 10. It must be an alkene. C6H12. If it has 6 carbons, it will be C. N is 6. 6 times 2 is 12. Plus 2 is 14. It must be C6H14. And you can see the answer is hidden there as D. And that is where you will get your 2 marks. That is our alkane. That is our saturated hydrocarbon. So you can see, if you got the understanding, you are able to apply all your knowledge and collect as many marks as possible. Now, let's look at this one. We're saying, which one of the following is a secondary alcohol? Remember, with your alcohols, it's not easy to see them, whether they are secondary, tertiary, or otherwise, when they are in this manner. But when you draw the structural formulas, you are having a carbon, and this carbon has 3 CH3s around it. That's the meaning of that statement, that in number A, it has 3 CH3s, this carbon, and is bonded to the OH. So you can see the carbon that is bonded to the OH is bonded to 3 other carbons. So this one is tertiary, this one, tertiary alcohol. So it does not fit to be a secondary, so it's wrong. Let's look at number B. Number B, you are having a CH3, which is CH3 like that. And then you are having CH2, first CH2, second CH2, and third CH2. So you have CH2 times 3. Those are the 3 I've drawn. After that, you are having OH. And you can see the carbon that is bonded to the OH is bonded to one other carbon. That makes this a primary alcohol. Now, let's go to number C. Let's draw its structure. Is CH3, is a carbon. And then you have 2 CH2s. So you know, if it's CH2, is part of the chain. And you have a C and an H. And you can see this carbon is running short of 2 bonds. So CHO to be that. So this is an aldehyde is not an alcohol, so it does not pass. Let's check the last option, whether it passes to be a secondary alcohol. Let's draw the structure. You are having a CH3, so you draw the CH3 there, you draw your CH2, you draw your CH, but this CH in bracket it has an OH, which means we have an OH there, and then you are having your CH3. You can see the carbon bonded to the OH. The carbon bonded to the OH is bonded to two other carbons. So you see that this is secondary alcohol is hidden here. Is your number D. I hope that helps you. It makes you to remember and to know that this type of questions you can collect marks. Now let's look at this one. Which one of the following is a hydrolysis reaction? Just put reactions in terms of a multiple choice just to bring your understanding as well. Remember, hydrolysis is a substitution reaction. Remember, under addition, this helps us. Under addition, we said we're having halogenation, we're having hydrogenation, we're having hydrohalogenation, we're having hydration. So when we are using water, here, we refer to it as hydration. Hydration in terms of addition. So we have 4 addition reactions. And then this one, it cannot be addition reaction because we can only add when we have unsaturated hydrocarbons in our case. So we don't have an alkene here. It must be an alkene so that we are able to add. So it cannot be addition, this one. So it's not hydration, because if it was addition and we are adding water, it will be hydration. Now let's check. Can it be elimination? No. When we eliminate, we must be able to form unsaturated hydrocarbon. So it's not elimination, it's not addition, it's not elimination. So hydrolysis must be substitution. Remember, we have those three major types of reaction, plus esterification, plus your combustion. Now, substitution, that's where we have hydrolysis. Hydrolysis is part of substitution. In this case, you can see, how do you know, say we are substituting? I know, because we're having a bromo here. Now it's substituted with the OH. Hence, we don't call it hydration, because we are not adding water. We are only substituting or replacing. We are replacing bromine. We are replacing bromine with the OH. Hence, we call it hydrolysis. I hope you see it clearly there. So you can see that this is hydrolysis because we are replacing the Br with the OH there. And then you are able to see that number A will be our hydrolysis or substitution reaction. Specific name, hydrolysis. So it's good that the answer was in number 1, so I won't have to go through the whole of it. Now, the letters A to H in the table below represent 8 organic compounds. Now, this was final exam 2023. We're saying define the term organic compound. You see, in terms of definition, there is no definition that is not important. You can see how our exams are now. It's important that you know, because you can find a definition that say define halogenation or define hydration, define hydrohalogenation. So all the definitions that you have, know them, because there's no definition that is less important. Look, in 2023, learners were asked to define the term organic compound, and we said these are compounds that contain carbon containing compounds. So it's important that you have that knowledge of saying these are carbon containing compounds, and then the study of carbon containing compounds, and we are referring to it as organic compound. Remember, organic compound, we are saying these are compounds that contain carbon. Now, write down the IUPAC name of compound E. So from the start, we want a name here. Compound E, you nicely simply go for it. Remember, your first point of entry is to look for the functional group. We said the functional group is that which differentiates it from the alkane. So that simplifies you to say we are looking for something that makes this different from alkanes, and then you are able to see that this is the issue. This is the carbon-carbon double bond. So you can see, and we said when we are numbering, we're going to prioritize the functional group. So this becomes carbon number 1. In carbon number 1, we have a double bond. So you say 1 in number E or alphabet E, is 1-ene. Now, the longest carbon chain will tell us about the parent. How many carbons? We have 1, 2. If you go to the right, you'll have only 3. So that is not the longest carbon chain. Let's go to the left. That will be 1, 2, 3, 4. It doesn't matter. You can say 1, 2, 3, 4, or 1, 2, 3, 4 is the same. So that you know that 4 is put. 4 carbons is put. So you know this is put 1-ene. But do you have any visitors? Yes. Do you have any substituent? Yes. In carbon number 2, we have a methyl. In carbon number 1, 2, you have a methyl. Carbon number 3, you have another methyl. So you'll know that it's 2,3 dimethyl. 2,3 dimethyl, put 1-ene. Don't forget, like terms, the number and the number, there is a comma. The number and the alphabet, there is a hyphen. Very much important. And because we have 2 methyls, you will call them dimethyl. So it's 2,3 dimethyl. If there were 3, we're going to say trimethyl. So it's important. So this is 2,3 dimethyl, put 1-ene, and then you got your 2 marks there. So you can see these papers. If you practice many question papers, previous question papers, you do you have the understanding of how to name, you will definitely get it. How did we name? We started with the suffix, the functional group. We said this is an ene, and where do we find the ene? It's in carbon number 1, hence we said 1-ene. We looked for the longest carbon chain. We said we have 4 carbons in the longest carbon chain. We said that is but. We said we have substituents in carbon number 2 and carbon number 3. That's why we call it 2,3 dimethyl, put 1-ene. So you're able to get that. Now 2.2.2 H, the IUPAC name of H, and then you are able to check and say, okay, let's check. This is own. It's a ketone because it has a functional group there. Remember I said because we're having 4 carbons here, 1, 2, 3, 4. You are not in any, you don't have any responsibility of showing us the where do we find the own. So this will be butanone. It has no a positional isomer, so you can just write it as butanone, and then you are able to get your mark there. So I hope you are moving together and you got your 2 marks there. That was 2023. Now write down the structural formula of compound B. Now if we look at compound B, you can see that most of our questions were being given condensed structural formula to draw. So it's important that you understand the condensed structural formulas and be able to see that, okay, let me start from this side, CH3. I will write CH3 like that. Remember structural formula, we are saying show all the bonds. Show all the bonds. We have 3 CH2s. So it's a CH2, another CH2, another CH2. So it's a CH2, the first one, the second one, and the third one. That is CH2, close bracket 3 there. So those are the CH2 times 3. We have a C with a double bond and an O, and then we have a CH3 there. You can see this is an ester. It's coming all right. This is an ester. You can see that structural formula of compound B. And a science learner already with a questioning mind, with a problem-solving mind, will say, I know that the CH3, this one, the CH3, this one with an O, is the one that comes from the alcohol. And that alcohol with 1 carbon, you know that this comes from methanol. It comes from methanol. And then you are able to know that, okay, it was methanol. And the one with the C double bond O, you know it's from the carboxylic acid. Remember, esters are formed between alcohol and carboxylic acid. And in our case, we are using primary alcohols and your carboxylic acid. So it will be methanol, and an acid had how many carbons? 1 plus 3 plus 1 is 5, which is 1, 2, 3, 4, 5. So you can see that this was pentanoic acid. So it was pentanoic acid plus methanol that formed this, which means the name of the structure will be methyl pentanoate. It's important that you analyze this. And the catalyst for esterification, we said, is sulfuric acid, H2SO4. All that information helps you as you move with the question, because if such questions come, you are able to respond. Now, structural formula of compound C. In this case, C is hexane, so you know it's 6 carbons. Hexane is 6 carbons. You draw the 6 carbon. Remember, each must be having 4 bonds around it. So we don't have an oxygen or double bonds there. So you just write like that. And then we're saying this hexane, it has a difluoro in carbon number 3. So in carbon number 3, 1, 2, 3, you can say from the left or right, it doesn't matter. So in carbon number 3, you have a fluoro and a fluoro. And in carbon number 4, you have an ethyl. Remember, ethyl is your CH2, CH3. Okay, let me write it at the bottom here. I'll put a hydrogen there. Then we'll have a CH2 and a CH3 here. A CH2 and a CH3 here. So in terms of that, you are able to draw your structure, and then you got it there. You got your structure is hexane that has visitor called halo. So it's a halo alkane, this one. So in carbon number 3, we have 3,3 difluoro. In carbon number 4, we have an ethyl, and the longest carbon chain is hexane. So it's important that you are able to draw that, and then you are able to get your 3 marks. Remember, you'll get marks for writing that whole parent chain correct. You'll get marks for your substituent as well, and then the marks for the whole structure correct. Then imagine that is 1% of your paper. So we're saying please practice as many structures as possible. General formula of homologous series to which compound E belongs. So we're saying compound E belongs to, what is the general formula? So you just go to E. And so these ones are alkenes, and alkenes are CnH2n. Remember, alkenes are CnH2n plus 2. So when you remove the 2, you get alkenes, which is CnH2n, and that's where E belongs. Remember, because of that C carbon-carbon double bond, these are alkenes. Now, structural formula of the functional group is important. Functional group. So you are looking for functional group of what? Of F. You just go to F, you can see it's a ketone there, C double bond O, and then you write a C double bond O. That must be surrounded by 2 carbons. Don't make a mistake. That is a ketone. It's a carbonyl group. You don't have to indicate the hydrogens. You just show the carbon with 4 bonds around these carbons. Let me draw the structure nicely. So you are saying C double bond O, and must be surrounded by 2 carbons there. And that is the functional group of compound F, which is the functional group of ketones in this case. IUPAC name of alcohol needed to produce compound B. Already I've helped you there. It's a CH3 with the O. Remember, the one without a C double bond O. We said this part, it will be the alcohol side. So we're saying, what is the alcohol? We said it already, that must be methanol. So you see, analyzing the question helps you as you move. Write down the letters that the letters of the compound that is a functional isomer of compound G. So you can see G nicely, look at it, and you're able to see that we have 1, 2, 3, 4, 5, 6. So it's a C6. Remember, when you talk about isomers, you're talking about molecular formula. So it's a C6. How many hydrogens? Is 1, 4, 7, 8, 9, 10, 11, 12. C6H12. O2. So you are looking for another structure which is C6, and if you check it B now, is how many? You are having 3 carbons, another 4, 5, 6, which is a C6, H12, O2. So you are able to see that an ester and carboxylic acid. Remember, we said cake there. So you are able to see that, okay, for functional isomers is for a compound G is a carboxylic acid. Remember, it is a COO there in carbon number 1, and then its functional isomer will be B, because B now has the same molecular formula as that one. Chain isomers. So you are able as well to look for the chain isomers to say, okay, it will have the same number in terms of the same number of carbons now, and then you are able to look at that to say which one will be that one. Look at this one, number D is hexanoic acid, and then hexanoic acid as well, it has C6H12O2. So you can be able to see that this one and this one, they are chain isomers, you see, because they have the same molecular formula but different types of chain. This one has branches, You still see 6H12 with branches. Remember chains, different types of chain. It's a no branch or less branch and more branch. Hexanoic acid has no branch, and then G has a branch. So you're able to see that this D and G must be chain isomers. And then that was 2023. And then our last question in this one would be for you to be able to define the term boiling point. Remember, we said it's a temperature at which the vapor pressure is equals to the atmospheric pressure. Write down the conclusion that can be made for Kev P. Kev P is this one. You can see as the molecular mass increases, the boiling point increases. So that's what you will write. As the molecular mass increases, the boiling point increases. Explain the answer to question 3.2 in terms of structures of the compounds. So you can be able to see that as we move from molecular mass of 50 to 70 to 80. So as the molecular mass moves from 50 to 70 to 90 to 110, as we increase the chain length, because remember, as we are increasing the molecular mass, we're increasing the chain length. So as we increase the chain length, we increase the strength of intermolecular forces, meaning that more energy will be required to overcome the intermolecular forces, hence we'll have a boiling point increasing as well. Now, I wanted to give you a homework that you will do at your own time. You can just take a picture of that question. The letters is A to H there. You take that picture and you are able to do this at your own time. This is based on last year's question paper. I hope you will do it, and then you will answer all those questions. And then it continues. So we'll do 2.1. We'll do 2.2 as well. You take the picture, or you just look for the question papers. I'm 100%. I'm sure that at your school, those copies of those question papers are there, and then you can just go and then you answer the last year's question paper as your homework. 2.1, 2.2, 2.3, and 2.4. So you will answer all the questions from last year's paper with 18 marks, so that you see your understanding of this one. So you're going to do that one as the homework, and we are expecting that you will answer all questions in question 2 from last year's question paper. You can do the same with question 3 as well. Now, I just want to summarize our lesson to say, remember, we emphasize the issue of International Union of Pure and Applied Chemistry to say, as we name, we must name the same, all of us in the world, not specific for us. We said we will first look for the functional group. In this case, our functional group, you can see in carbon number 2 there, we have the OH. Functional group is this one. This is the functional group of alcohols. This is carbon bonded to the OH there. And then we said we call it hydroxyl group. Now, you will see that this is a 2-all, because the functional group is in carbon number 2, and then we're saying the longest carbon chain is 1, 2, 3, 4, 5, 6. So this will be hexane. Remember, you can't say hex. It's saturated. It must be hexane 2-all. And then we are saying, do we have a substituent? Yes. In carbon number 4, we have a methyl. So this will be our 4-methyl hexane 2-all. So you can see that the suffix is from the functional group and the position as well. The longest carbon chain gives us the parent. The substituent now, which is a methyl in carbon number 4, is the prefix, and that's what the name will always start with in terms of that. Now, when I conclude, the summary based on physical properties is to always remember we're doing only 3 physical properties, which is your melting point, boiling point, and vapor pressure, and we have defined them. Always remember the definition of boiling point. We're saying it's not a point, it's a temperature at which the vapor pressure is equal to the atmospheric pressure. The melting point, again, is not a point, it's a temperature at which the solid and the liquid phase of a substance are at equilibrium. And vapor pressure, we're saying the pressure exerted by vapor at equilibrium with its liquid phase of substance, they are that at equilibrium. And then you know that in terms of our independent variables, or what we change the intermolecular forces. In this case, we change the functional groups. As we change the functional groups, we're changing the intermolecular forces. So you will see what will be different. It will be the intermolecular forces, which is the functional groups, and then it will be the chain length, longer chain length, shorter chain length. It will be the branch. In this question, I think we had many questions that were asking about branches as well. So I would like you to always have that. And then we are saying we preview our next lesson where we'll meet and be doing again a lot of work to say just in time when is next term will be meeting. And then that will be on the 11th of April 2025. Still this year, we'll be meeting again. And the topic that we'll be dealing with then, the time will still be 2 o'clock to 3:30. And then we are saying the topic will be work, energy, and power. So I hope you will be dealing with that. You'll be looking at that. Remember, here you are focusing mostly on your forces. Remember, you've done Newton's laws. Your forces, your free body diagram, your force diagrams, because it is those forces that are going to do work. So it's important that you have that understanding and you prepare yourself. And without any wasting of time, we'll always want to finish by saying this: anyone who has never made a mistake has never tried anything new. So keep on trying, keep on practicing as many question papers as possible. Those are the ways of Albert Einstein. And then I would like to say to you, thank you very much till we meet again on the 11th of April 2025. Thank you.